Hi, it's Kevin Lebates here, and today's video is a resonance security video. I don't have the resonance hat because the weather is fantastic and it's too warm to be wearing a hat, and I don't have my resonance t-shirts because my son has decided he really likes them and has taken them all from me. But anyway, my personal woes regarding clothing aside, what I wanted to talk about today was the topic of the risks in implementing security on computers, because we have all this cryptographic knowledge for things like digital signing and authentication and identity, cryptographic hash functions, all these tools at our disposal. But it turns out that these tools are very subtle and difficult to implement. And so if you're a developer, there are all sorts of traps and pitfalls that you can fall into when taking the academic knowledge and trying to turn it into something practical for a computing system. And in fact, it's probably a bigger cause of problems in computer security than flaws within the actual cryptographic schemes that we use, although we are finding flaws in cryptographic schemes all the time as well as people poke away at them. So the last couple of weeks I've been working on some mathematical stuff to do with cryptography. I was looking at ECDSA signing in particular with Jamie Gilchrist over in Scotland, and we found a few things about ECDSA which would not be immediately obvious to a novice if they were working on implementing a digital signing protocol using elliptic curve digital signing algorithms. I won't go into the details of the mathematics, but it turns out that you have to be very careful on selecting random numbers when you're producing the digital signatures, and if you do anything predictable in the process of digitally signing, then it's possible for a hacker or a malicious party to extract your private key. And of course, that's an absolute disaster in blockchain, because all digital assets are protected by requiring authorization with a digital signature to transfer them. And it made me think that that's a bit of a problem in the computing world, because somebody coming to ECDSA and reading the papers on it and implementing the protocol themselves wouldn't know all these surrounding issues of the protocol immediately. You have to read quite widely to find out what all the known flaws are. And unfortunately, there are plenty of hackers out there who do know these flaws, and therefore when a new digital wallet appears on the market, they immediately start seeing if they can find those flaws and exploit them. And I've also seen this with computer contracting companies, where if you're a startup and you don't have the in-house experience, you might be tempted to go to a consulting company and saying, can you build our site and handle the code required for secure logging in and for the encryption of messages and things like that. And a lot of companies out there that don't specialize in security will say, yeah, sure, we'll do that, because as far as they're concerned, it's money in the bank. It's a contract, and they deliver some code that on the surface of it looks like it does exactly... Oh, there's a helicopter flying over here. What's the point of living in the middle of the wilderness if when you go for a walk you can't avoid all this noise? I wonder what they're doing. Anyway, sorry, distraction there. So I was talking about contracting companies that will write the code for you if you don't have the in-house experience. They're going to say yes most of the time, because the sales guys just want to make a sale, and then they go and find a developer in-house who says, yeah, I know a bit about that, and they start implementing it. And when you receive that code, if you're not experienced and you don't know about security testing, then you're going to take it and try it, and the login works fine and the messages seem to be encrypted and all that kind of stuff, and you'll pay up, and now you have an insecure product. So I guess the point I'm making here, in a rather rambling, long-winded manner, is that if you're going to do anything that requires the system to be secure, and let's face it, pretty much every system now should be secure because you're handling often personal data of people, then you need to go to companies that have a track record of knowing how to handle computer security, that know what they're doing. And that can be difficult because, of course, no company is going to advertise the fact that they have weaknesses in certain areas. They only advertise that they're strong in certain areas. And as a result, my recommendation is, if at all possible, find a company that specializes in security when it comes to these specific parts of your project or your product or your system. Anyway, just thought I would talk off the top of my head while going for a walk in the Finnish forest. It's a beautiful sunny day, so much better than sitting at my desk. I hope amongst all the rambling you found some stuff of interest here, and I'll shut it off for now and see you in the next video soon. Bye for now.